We're always looking for speakers for TVUG. If you'd like to do a presentation, please reach out to us at meetup.com/TechValleyNetUserGroup. Looking for other user groups to attend? Please visit meetup.com/.net-virtual-user-group.
Well, welcome everyone. It's exciting to speak to your group. I think it's the first time visiting this group, but I'm thrilled to do so. And I don't know about you guys, but here in Texas, summer and winter are still fighting over the state. It was 80 degrees last week and just down in the 40s this week. And so, but we are going to talk about Blazor today, and not just about developing Blazor applications, but we're going to talk about the architecture patterns that are starting to emerge. People around the industry are starting to talk about just the rules of thumb, given several years of actually using Blazor at this point for the early adopters. And for myself and my role and how I came to learn about these patterns, I'm one of the chief architects at ClearMeasure, which is a software architecture company headquartered out of Austin, Texas, but serving clients all over the country. And what we do, just kind of the day job, is to help teams that have internal .NET development teams to either move faster or increase quality or run their systems with confidence in Azure or wherever they happen to be. And all the time, for almost every situation, there's some architectural solutions that are missing, that are hindering moving faster, hindering the quality, or hindering the stability of the system in production. And Blazor has been a really popular new application type, not only for net new applications, but also for adding on a particular process to an existing larger system that's already pretty sprawling anyway. It has lots of independent applications surrounding the core. So I'm going to talk about some of the patterns that have become evident, and for the next Blazor application, there's some that I consider to be a rule of thumb now, and some of them are not particularly new as an industry goes, but we'll talk about how they can be applied in Blazor applications specifically. So a few resources as we go through. I'm the host of the Azure DevOps podcast, so if you're a podcast listener, you can just search for the word DevOps or Azure in the podcast directory, and it'll pop up in the first page there. And also, while it's been now 2 years since this happened, if anybody is interested in my latest book, I'd be happy to give you a complete PDF electronic copy of the manuscript if you just want to send me an email, and I'll put this email address back up at the end of the talk. So, and if you have any questions about the content or anything, I love answering questions, and just send me an email. So that'd be great. All right. So let me talk about some of the instances that have given context to this presentation. And I believe we have some microphones that need to be muted. Not sure who can take care of that. But one of the projects that was a really early adopter when Blazor first came out, even before Blazor WebAssembly was viable in the .NET Core timeframe, even before .NET 5, before .NET 6, was a auction system for various applications, for livestock auctions at fairs, for car auctions, all different applications. And the situation is certainly where you need a screen that interactively displays data, but there's a special intensity around an auction that when a price changes, you need to know that price changed right away, immediately. The page refreshes are off the table. You can't just poll and refresh every 10 seconds. Whenever there's a price change, whether it be a livestock auction or a car auction, those price changes, a bit of data needs to be actively pushed out to the clients. And so that created some interesting architectural requirements there. And this is one of the screenshots of the software applied to some livestock. And then also a different application kind of tangentially is an application for digital signage, and an application that effectively drives the big screen. There's no user input, and the only way to change it is from sending messages that the application listens to from a control panel. And whether it be a menu in a restaurant or otherwise, you can do some pretty interesting and dynamic digital signage applications to display things and then control it from a side control panel application. But the categories, so before we go into the categories, the experience over the last few years of just a couple samples that I just showed you, but a whole lot of Blazor work have emerged some rules of thumb, some gotchas, some things to watch out for, and some guidance that Microsoft is not going to provide, because Microsoft provides options. Whenever you ask Microsoft a question of, hey, what's better, A or B? The answer is, we support both. And of course, that's what you're going to get from a framework provider. We support both, and they do, because there's people out in the marketplace that need both. And person A may say, why would I ever do it that way? I'm going to do it this way. And they're right. The other person says, why would I ever do it that way? I'm doing it this way. And they're right, because there's all kinds of different situations. But I'm going to talk about some experiences where I don't think that it's 50-50 of sometimes you do A, sometimes you do B. I'm going to talk about the instances where I believe the guidance is, 80% of the time, you want to do A, and maybe if you have an exception, go for B. But 80% of the time, and where you want to start until you maybe discover that B is attractive, okay, you want to do A. So that's where I'm going to come from to give some guidance on those kinds of things. So you can have some rules of thumb to know where to start until you learn something about your situation that may cause you to realize, oh, you know what, let me go ahead and change that aspect. So we're going to talk about architecturally how Blazor is different than other applications, where it's the same. We're going to talk about how the memory management of Blazor applications is unique from other .NET applications. Then we're going to talk about the broad applicability of hub and spoke patterns, which is a really old architectural paradigm, but uniquely useful in Blazor applications. Then we're going to dive into eventing throughout different parts of the user interface, because decomposing a user interface into components, you have the need for components to maybe talk to each other or pass information around. Then we're going to talk about how to actually test Blazor applications in different ways. And then finally, we're going to close up with looking at what monitoring looks like for a Blazor application that's running in production on Azure. So let's start architecturally. And I want to talk about how to build a Blazor application by talking about the DevOps environment first and the different components. Now, I've taken and annotated a DevOps architecture poster that has been around for a long time, but annotated it with the Blazor icon for the parts of the DevOps environment where you have to do at least something special because you have a Blazor application, and the parts that don't have the Blazor icon are the areas of your DevOps environment where you literally don't have to do anything because it's Blazor, and it'll work just because it's .NET. Okay. By the way, if you would like a high resolution version of this poster, be my guest. Just send me an email, and I'll make sure that you get it. This is actually the top third. I can't go into all the detail on it, but this is the top third of the full kind of base poster here, and we'll dive into it. Now, I'm not going to go into every bit of detail here. However, I do want to say, when it comes to the deployment area, you'll see that we have 3 environments depicted here. And I know the text is a little bit small, but you have the first line environment. I like to call it the TDD environment to invoke test-driven development, because we need a first environment where we deploy something. And the first time we deploy it is the first time we figure out if this particular version, if this particular build is even going to start up. I mean, we could have done something that totally makes it bomb on startup, and we can't even give it to a real person to test. And so we need an environment to test that and to run automated full system tests. So I think it's appropriate to call that first line environment the TDD environment. The next environment type is, I like to call the UAT environment, user acceptance test, and then the third environment is production. This is the minimum that you'll ever have. The minimum number of environments you have in Blazor or any application is 3, because there are 3 distinct types of environments, and you need at least one of each. Everybody needs production. You need at least one production environment. You could have multiple production environments and segment your users. That's totally fine. But you need at least one. Backing up from that, you need an environment where a person can check something. That's your generic test environments of all sorts. You need at least one. A lot of organizations have multiple test environments, and that's great, but you need at least one. And then backing up from that is, for the development team, we need an automated test environment to test whether it even starts up or not, to do test deployments on feature branching to see if we even want to approve a pull request of a change that, well, we need to know if that change totally broke the installer. So we need to check that. And of course, you may have multiple of those. You need at least one. And that is a really important environment, because it is the third and final phase of the practice of continuous integration. There's a lot of people, we see this, unfortunately, too many clients that say, oh yeah, we have continuous integration in our environment. And we say, oh yeah, show me. And they have one of the 3 parts of continuous integration, which is you take GitHub Actions or Azure pipelines, and you just trigger a build based on a change to your Git repository. And they have the start of an integration build. That's important. That's one of the 3 parts of continuous integration. And your private build, which runs on the local developer workstation, that's the first part. And then your first deployment and post-deployment test suite, that's the third part of continuous integration. So, by the way, if there's anybody out there who hasn't read the book from 2006 titled Continuous Integration, I highly encourage you to read that book. It still sets a standard in the industry for what the practice of continuous integration is. And we just see a lot of people not implementing all 3 parts of continuous integration, and they're really, really important. So let's move on, and let me drill down into source control. Blazor is, the good news is Blazor is just another .NET application type. And as such, so much of how you store the source code for a Blazor application is the same. It fits inside a Visual Studio solution, and it works great with Git. Now, I will say, if you have a Visual Studio solution and multiple different teams are making changes to different parts of it, then you probably have 2 applications that are searching to get out, and you need to split up that Git repository into 2. Because while what I'm about to tell you isn't exactly unique to a Blazor application, it's so important, and if you get this wrong, you're going to be fighting against your environment the whole time. Any software system is likely, any large software system is likely going to be segmented into many different applications. Each application that is uniquely versioned. It's a logical application, and it has its own build, test, deploy, maintaining, servicing cycle. Now, the software system as a whole can be comprised over many of these, and each of the applications inside need to have their own schedule. And regardless of what flavor of segmentation architecture you like, whether you want the smart cohesive monolith, whether you want just basic segmentation into a couple of really large applications, or whether you're going more of a microservices flavor where you're chopping up that software system into very, very small applications that just do smaller and smaller things, regardless of where you like to land there, each of your versioned software applications need their own Git repository. All the products in the DevOps space are tested assuming that they're going to operate on all the code that's in a particular Git repository. So you want to make sure that you only have one. And of course, the unit inside the Git repository is the Visual Studio solution. So you want one solution inside one Git repository, and that goes for your Blazor applications as well. Now, I do want to talk briefly on the differences in Blazor Server versus Blazor WebAssembly, and try to clear up some confusion, because invariably, if anybody's looked at Blazor at all, they've seen the basic pitch on Blazor server running all your code on the server side, and then Blazor WebAssembly running all your code in the browser. Now, because of the order of release from Microsoft, Blazor server-side came around first, and then Blazor WebAssembly came second. However, that's backwards from how it was actually designed. Blazor was actually designed with WebAssembly first and then server-side second. But because server-side depended on some other bits of infrastructure like SignalR, it just fell into place really nicely and was able to be released first, but it was actually designed second. So the first-class citizen of Blazor is WebAssembly, and Blazor server-side was the next way of running Blazor that the team realized, hey, you know what? I bet you we can get it running on the server also. But it was originally envisioned with WebAssembly. It just took the WebAssembly version longer to come out. And there's some important parts that I want to highlight with Blazor server that you may or may not have already heard. When you go to the URL of your Blazor server-side application, the web browser, the web server, is actually going to give you a Blazor JavaScript file, which is effectively the Blazor application that's going to run in your browser. And the JavaScript file is going to immediately turn around and call back to the server and ask for a bunch of stuff. It's going to ask for what types of HTML elements it should start building into the HTML DOM on the browser. And the only code running in the browser is code Microsoft wrote. All of our code is running on the server and just responding to events. And if you hit the F12 in your browser and go to the messages, go to the WebSocket messages view in there, you can see all the different binary messages that are just flying back and forth. They're really small, they're binary, they're not human readable, but they're going. And so when it comes to Blazor WebAssembly, you're in control of when and if you call back to the server and hop over the network. On Blazor server side, you're not in control of that because absolutely everything causes a round trip to the server. So with Blazor server side, you are network latency and network jitter is going to be very, very important to you. And also server side response time is going to be very, very important to you, because if any of those three are not absolutely perfect and crisp and fast, then your application is going to appear sluggish to the users. Okay, and you're never gonna detect that running on a development computer, because your local host and your latency is pretty much zero, your network jitter is pretty much zero, and your server response time is a big honking developer workstation. By the way, I want you to all recognize that the computer that you use for writing code is likely more powerful than the server instance that you're going to be paying for running it in Azure or anywhere else. And so you really want to make sure that you test the application's performance and load on a really deployed server, representative server, so that you can detect if you have any of these issues. On Blazor WebAssembly, I mean, there's plenty of samples out there. There's even a sample of a calculator that, a calculator application doesn't call back to the server at all. So you are really in charge of how and if you make use of the network. So just be aware. Now, at this point, a lot of you are asking, okay, so should I use WebAssembly or should I use server side? And I'm not going to tell you it depends. Why? Because you're going to have both. You will. You are going to have some Blazor WebAssembly applications, and you are going to have some Blazor server-side applications. It's just going to happen. It's going to be that way. So you can stop asking which one is better, because you're going to have both. Now, I will tell you, if you want the fastest time to market or the fastest time to the first version that you can develop and get out there, Blazor server-side is going to give you that because it has fewer architectural concepts and it has fewer things going on. If you want more control over the use of your network hops and the bandwidth and all that, well, it's going to push you to Blazor WebAssembly. If you want to minimize your server costs in Azure, that's going to push you to WebAssembly. If you want higher guarantees that nobody using your application is going to be able to reverse engineer or even see any of the code in your application, that's going to push you to Blazor server side because those assemblies are on the server. As opposed to in WebAssembly, those assemblies actually get downloaded to the browser. So back in the days where every .NET developer was doing half of their development of desktop, WinForms, WPF, and half the development of web applications, there was a lot of talk over obfuscation tools. So if somebody got your DLL and they popped it open with .peek or reflector, how much could they see? And in WebAssembly or any application where the assembly, the DLL file is actually going to your user's computer, you may think about that. And in some cases, you might not have anything secret in there, no big deal. And in other cases, you might have some intellectual property that your business wants to protect, and you may want to do some obfuscation just to protect that intellectual property. So these two application types run in different places, and that's going to impact your decision. But you are going to have some of each. So it's not just is one better than the other. You're going to have both. All right. So let me highlight some architectural runtime aspects on Blazor server side, just kind of born from experience, born from some early mistakes. We kind of figured out these matter. They weren't particularly obvious, several years ago, but now it's just do it this way. These are the Azure settings for the hosting plan application, .NET 6. 64-bit is the next one. You want to make sure that you're using 64-bit. So many people forget this. Why? Because you start the first environment on the free tier in Azure, and the free tier doesn't support 64-bit. It's 32-bit by default. So then you upsize your instance type, and if you don't come back in and change the platform, well, now you may have 8, 16 gigs of RAM on your server instance, but you can't get more than 2 because you're still on the 32-bit setting. Okay. Just jumping down to WebSockets, again, the free tier, and maybe they'll change it at some point, but your free tier doesn't support a lot of these settings. So once you get past the free tier and onto the premium, you want to come in and make sure these settings are on. WebSockets, if it's off, SignalR is going to fall back to long polling, and while it can functionally work a little bit slower, it's going to use up a lot of CPU just because the web server is using long polling. So you want to have WebSockets on so that your browser can properly keep a persistent WebSocket open back to the server. By the way, you also want to offload your SignalR to Azure SignalR service. Once you get into production, you really don't want to continue to host your SignalR hub in your application itself. You want to offload it to Azure SignalR service, which is super, super easy, doesn't require hardly any configuration. And then the last setting, ARR affinity, this is your classic sticky sessions. And on Blazor server side, because this application is stateful, think about running multiple instances of a desktop program and allowing people to access it with remote desktop. Well, if you were to jump over to a different server, it would just start the application fresh and go to the home screen because it doesn't know the state of the UI. It doesn't know what page you were on, any of those types of things. Blazor server side, that's kind of what it is. It's not a Windows desktop app, but it's a web app, but it's a stateful application, and you're running your user's session on the server and just letting your users remote into it via the web browser. So think of it architecturally, that's what it is. You are running multiple instances of the application for your user, and then their terminal or their remote session is coming in via the browser. All right. Whereas in WebAssembly, their browser is actually running the application, and the CPU of the client computer is being used, the memory, the RAM of the client computer are being used, and then at some point you choose where in the code you actually want to jump over and ask the server something, and the server is just providing various endpoints of which you're always going to have multiple. And by the way, in any of these applications, you're going to have synchronous blocking calls, which is probably an HTTP web service, whether it's web API or minimal APIs. You're going to have blocking synchronous but not guaranteed delivery communication. That's going to be over a SignalR hub. Then you're going to have non-blocking asynchronous communication, which is probably going to go over Azure Service Bus with a queue. All right. And then those are the three. Those are the big three. Now you could have other types of communication, but those are the three that you need to support in so many applications. And so a lot of people think, oh, if I'm calling into the server, I'm going to use a web service. Well, only if you want a blocking synchronous call. If you don't want a blocking synchronous call, don't use a web service. All right. Okay. So AR affinity turned on. Oh, by the way, if you miss that setting and you start scaling up your environment or scaling out your environment horizontally, and you go to the web farm configuration by having more than one instance to your hosting plan, then that's when you're going to find some bugs, because the load balancer is going to be sending your user to multiple different instances, and the memory will be on server A, but then you got routed to server B, and it just starts sending the user back to the home screen. They lose what they were working on. So don't do that. Okay, let me talk about the solution structure for your Blazor application. And I'm going to use as an example the car auction application. And some of you may look at this and say, hey, it looks kind of familiar. There's a project called Core, which is a telltale sign of onion architecture. And if you aren't familiar with onion architecture, just do some online searches and you can kind of spruce up on that. But effectively, it's just I consider the 80% case. Regardless of what application type you're working on, you want to organize your Visual Studio projects in the onion architecture fashion, because it really helps your team manage the dependencies that you have. When I say dependencies, I mean NuGet packages. Which projects in Visual Studio are going to reference which NuGet package libraries? Because the worst thing to do is to have all of the projects in your entire solution referencing all of the NuGet packages that you choose to use. That's a terrible thing. Instead, you want to organize those. You don't want code that is just modeling a customer or a product or an order to be in a project that, for instance, references Entity Framework. Your entities, yes, they're entities, but they shouldn't live in a place that actually references a data access library, because then you're coupled to that method of data access. You're coupled to SQL Server and whatnot. Just like they shouldn't live in a project that references any kind of web framework or any of the Blazor assemblies, because what about using those entities in a Maui application? Your entities, those core objects that represent what your application is, they should live in a very clean, minimalist library. And Onion Architecture literally calls it Core. And that library is very clean of dependencies. It doesn't reference anything hardly, except the basic libraries that allow C# objects to exist. So you can see everything references Core on the top left. Core is at the top and everything references down. It's very common, we found, with Blazor to separate the different permission-based segments of the application into different projects. And with web applications, our industry has tried to craft permission sets where, a certain part of this web application can be accessed by this user, but not that user. And ASP.NET even has, authorization attributes where it has some support for that. In Blazor, we found it much, much more straightforward to have, say, a public application. In this instance, it's called UI for user interface. And then for an admin application, which maybe only one or two people actually can get to those screens, just make another Blazor application, UI.admin. After all, the performance characteristics or the load characteristics of these two applications is vastly different. Typically, the public application, in this case UI, is going to have much greater load on it than the admin application, which is used by two people. So then you have some segmentation on server resources, and you don't have to scale up both of these. Maybe you only have to scale up one. They have different user bases, so they have you get more flexibility in controlling that. All right, let's go on to memory management. And this is where WebAssembly and server-side Blazor diverge a great deal. And I'm going to talk specifically about the inversion of control container that's built into .NET 6 and how they do memory dependency management. The three levels of dependency management that you get in .NET these days is singleton, scoped, and transient. And that's great. Singleton is no matter how many times you call it, you're going to get the same instance of the object. For scoped, by the way, it only makes sense in a web lifecycle. You're going to get, no matter how many times you call it within the life of a particular web request, you're going to get the same instance of the object. And with transient, every time you call it, you're going to get a new, brand new instance of the object. That's great. All right, so let's talk about WebAssembly. In WebAssembly, transient, yep, it means transient. Every time I call it, I get a new object. That's awesome. Scoped, what does that mean? Life of a single web request. Well, I called the web request, I loaded the WebAssembly application, and that's it. So if I call scoped, the web request never changes, so it kind of appears like a singleton. Well, for that particular user, okay? Because the process that's running it, which the process owns the memory space, is running in the browser. So for all the calls that happen in that particular browser, I'm going to get the same instance of the object. For all the calls that happen in other browsers, they get different objects, okay? So for scoped, it's not the life of the web request. It is, well, it is, but because it's Blazor WebAssembly, it is the particular Blazor assembly user. And for singleton, well, in Blazor, it is for the life of the process, but in WebAssembly, the life of the process is actually the same as the scope of the web request, which is the user session. So in WebAssembly, you basically have transient and you have scope singleton, because scope or singleton will, in effect, demonstrate the same behavior in a WebAssembly application. In server side, not the same. Transient, okay, yeah, it's transient. For scoped, it's going to be the life of the web request. Now, let's talk about this, because in a Blazor application, which by the way, the base of a Blazor application is a ASP.NET server application, okay? So in the same process running on a server, you're going to be serving up Blazor pages, but you're also going to be serving up web services, okay? So if we have a call, if we get an object via scoped in a web API controller, we're going to get a different object every time that web API controller is called because it's different requests. But for the same web application, if I'm inside a Blazor component on Blazor server side, that doesn't happen. I get the same object. Why? Because when I call a URL, the server actually sends back the Blazor JS file, which immediately calls back and opens up a WebSocket back to the server and sits there. And then all the back and forth for hours and hours and hours happens over that WebSocket connection. So for that Blazor component, when do we ever get a new web request? Never. Never. Even when I navigate to a new page and the URL in the address bar changes, that's just fakery. That's just the Blazor framework telling the browser change what's in the address bar. That's not actually a new web request. So for Blazor server side, scoped is not giving you the same behavior as scoped is inside a web API controller. It's giving you effectively per Blazor user session. Now, it's not exactly user session because a particular user could force a refresh in the browser, which would cause a reload. And guess what? Now we have a new web request, and so we're going to get different objects. Okay. Singleton, we're going to get one instance of the object per process. But let's think about where the process is. The process is on the server. Now, if you have one web server, it's not you're going to get the same object over and over and over again. And the second user and the third user and the fourth user code running for their sessions is also going to get the same object because they're in the same process. On WebAssembly, it's not the case because every web browser is hosting a different process. So every user ends up getting different objects. So Singleton on the server is pretty straightforward until you start to depend on it, and you start to depend on every user of your application getting the same object, and maybe you put a property in there that stores some state, and then your application scales, and then you go to Azure and say, hey, why don't you give me 2 server instances? Well, guess what? Now your application has 2 server processes, and all the users who are pegged to server A are getting 1 instance of the object, and B is the other instance of the object. And if you've depended on sharing state through that singleton, now that's broken. Okay, so it's important to understand how the memory is being used in the different flavors. Also for Blazor server side, there is a built-in 3-minute timeout. Whether it's on a smartphone and somebody hits the screen, put it in their pocket. Well, guess what? Your smartphone hibernated that tab on the browser. And so effectively, from the server's perspective, the client went away. And of course, networks, various types and Wi-Fi kind of drop and then come back up and drop and come back up. And so this Blazor server side, the framework is going to do this for you. It's going to save the state of that particular user's session for 3 minutes, listening to see if that client is going to come back, if it's going to connect, if that WebSocket is going to get reconnected. And if it doesn't get reconnected after 3 minutes, then all that memory in the user session is going to be garbage collected and thrown away. And if the user comes back, it'll basically start over and they'll get thrown to the home screen. Okay. For Entity Framework, by the way, there was a bug early on because the add DB context extension method actually calls add scoped under the covers. And Entity Framework is basically only used on server-side Blazor. We tend not to use it in WebAssembly, except some really easy, really interesting SQLite capabilities are coming out for Blazor WebAssembly. Steve Sanderson showed some of that at the .NET Conf in November of how SQLite can be used with Entity Framework in Blazor WebAssembly as a client-side data cache of some sort, and they're making that better. But for the meantime, on the server side, if you're using Entity Framework, you'll want to use the particular documentation that's shown on the screen, and it shows a pattern for creating a factory so that you can get your data context instances properly segmented and not accidentally reusing the same data context more than is appropriate. All right, just throw that out there. Let's move on to hub and spoke. I would say in the 80% case, every Blazor application needs to make use of a hub and spoke pattern. Hub and spoke is an abstraction that basically creates a pinch point so that the user interface of your application, in this case your Blazor components, calls literally the same abstraction to get a request into the rest of your application or into the back end of your application. So instead of having, which very, very popular pattern 10 years ago, and a lot of people still use it today, repository interfaces, instead of taking repository interfaces and injecting them into properties in a Blazor component, you would instead create a query object or a command object and pass it down into the back end of your application. Whereas using repository interfaces causes many, many, many interfaces to be injected into your Blazor components, and it also creates a lot of touch points from the front end to the back end, hindering instrumentation, hindering caching, and hindering other cross-cutting concerns. But if you use a hub and spoke pattern, then for your entire Blazor application, you create that pinch point. So everything going from the user interface to the back end of your application, everything goes through the same abstraction. And now you can have other code that kind of observes everything that people are using your application to do. The diagram on the right kind of shows that. And by the way, if any of you are not using or not Git committing your architecture and design pattern diagrams into your Git repository, then I would highly encourage you to start now. This is actually using the PlantML tool with the C4 extensions. And effectively, this diagram is created kind of like Markdown. The source for this diagram is just text, is just markup, and it's stored as text files in the Git repository with the source code of your application. And it's a little hotkey in VS Code or wherever you want to run the visualizer, and it takes the markup for your diagram and it just spits out the image. So whereas in Visio you actually have to move around glyphs and whatnot, with PlantML you can just change text and it kind of just auto generates your architecture diagrams. So if you're not already using this style of I would say merge commit or Git committable architecture diagrams, that's something you might want to look into. So on the left, we have a implementation of a bus pattern, which is one of the hub and spoke patterns. In general, the hub and spoke family, it's kind of a way of thinking. You have the hub of a wheel, and think of an old-timey wagon wheel. You have the hub, and then you have all kinds of spokes around it. And so flip it on its side, and a request comes into the hub. And then through some type of logic, the request gets routed to one or many of the spokes. And in hub and spoke, all the intelligence of the routing belongs to the spokes, not the hub. If you want to split hairs, if the intelligence of the routing was in the hub, then you would call it a broker. And they're perfectly fine design pattern, but it's just which do you want? And typically when you are creating an application, you want to get going with a few spokes and add spokes along the way. And so in an emergent application like that, you want the spokes to have the routing intelligence so that you can add spokes on the fly without the hub having to change. And if the hub had the routing intelligence, well, then the hub would actually have to know about the existence of all the other spokes in some sort of fashion. So anyway, that's just the nitty gritty of design patterns. But I don't
Jeffrey?
really like to. Yes, sir.
We do have a question. What is the definition of the backend in this context? Is it external web API or repository pattern?
Oh, okay, good question. Yeah, when I say the backend, I'm really generally referring to not the user interface layer. So in a Blazor application, your UI is your Blazor components. So if there is code inside your Blazor components, by definition, it's in the user interface. It's at the kind of edge of the application facing a person. And so there is no real definition of backend, whatnot. It's all the same process in a Blazor server-side application. And on a WebAssembly application, you can have two backends. You have your WebAssembly process in the browser, which has a front end and a back end. And then the back end of your WebAssembly process is going to call out to a web service, which by definition is a front end of the web service, until the code actually leaves the web API controller and gets further back in the code where it gets closer to a database. Does that answer the question? Okay, I'll assume it does. All right, so this hub and spoke pattern, here's an example of just implementing a bus, which there's many many classes that kind of subscribe to whatever gets sent down the bus, which is the hub. And so we can create a auction entry query object, or it's a query, but it's just an object. We pass it down the bus and it gets routed somehow, and we get back the entry. And then we can also send a notification to any interested party that, hey, you know what? This entry was refreshed. This car that we're selling in the auction was refreshed. Some of the data changed about it, so you need to refresh it. So that's kind of what that can look like. And this refresh data method is inside of a Blazor component. All right, let's keep rolling. So I would say every Blazor application needs a bus. And at the minimum, you need a place to send a request and then to publish an event. I love creating a bus implementation that actually uses the mediator library to do some of the spoke or the handler registrations with the hub, because it's a library that does that really well. There's no reason that you should have to write that code yourself. It's not that much code, but there's no reason you need to write that code. And so I really often wrap the mediator library and use that in my bus implementation. I don't ever want to, no, this isn't just a 80%, this is like a 99%. I don't ever want to use the abstraction that is defined in a third-party library, like the mediator library, all over my application, because then I'm taking an implementation detail from a library and I'm making it a first-class citizen in my application. And you could say, oh yeah, but no, this library gave us the abstraction. Okay, yeah, until it changes. Okay, so it's so easy to make your own abstraction. You want to keep all these third-party libraries at arm's length and only have code that references their types in one isolated part of your application. That's been true since the dawn of programming, so that's not a new concept. But this is a great bus implementation, and it allows cross-cutting concerns, whether it's logging, whether it's telling application insights to record a call or do a custom event or anything. It allows cross-cutting concerns because literally every button click, every screen load of every Blazor component is sending objects, sending requests, queries, commands, events through bus.send. You have one pinch point in your entire application for those, and then you also publishing of notifications that can be consumed by multiple people. All right, let's keep going. Got a lot of material here. So I'm just going to, I talked about this. All right, UI eventing. The UI in a Blazor application is stateful. Don't plan on browser refreshes. If any of you have done other types of SPA applications, React, Angular, or have done desktop applications, like significant ones with WPF or WinForms, you're going to want to bring back some of those patterns for stateful UIs. And it's going to become really apparent when you start to factor your screens into many components. And the Blazor project right out of the gate, the template for File New Project in Visual Studio, it really doesn't give you a whole lot of segmenting of the user interface. It actually kind of leads you to build an application similar to how you would build an ASP.NET MVC, which is not how you want to think of it. You want to think of it more of a desktop application and factor out sections of the screen into different components. Then you're going to immediately say, how do those different sections of the screen communicate with each other? And that's when you're going to start thinking more about eventing, because trying to have the layout talk to a component or a parent component push something down into its child component, which, oh, by the way, then has to push something down to its child component, and you start going up these ancestry trees. Now you get spaghetti code in the user interface, and that doesn't work. Okay, so you need some communication mechanism throughout the user interface, and that's where UI eventing comes into place. All right, so let's talk about UI eventing. You see the component up top that says refresh timer. This is a component inside the car auction application, and there is a timer. In addition to real-time notifications, there is a refresh timer that effectively says, you know what, every so often, I'm just going to just in case I missed one of those real-time notifications, which by the way is through SignalR, which by the way is not guaranteed delivery. So we add this on just in case maybe I missed one. I'm going to go ahead and refresh all my prices, on a configurable number of seconds. All right. And so there's that refresh timer component. But let's dive into how we implement the refresh timer. Guess what? This has no markup. There is zero visual element of the refresh timer. It only has behavior. And so look at this behavior. All we're doing is using a timer, getting configuration keys to see how frequently we should throw a refresh event. And then right in the middle of the screen, you see bus.notify new refresh timer triggered. That's an event object. And it's an empty object. It has no properties. It just is. It's an event. And so we say, hey, bus.notify. Well, notify who? Notify whoever wanted to be notified. Okay, so we have some components around the screen, and for them to get this notification, they just need to implement an iListener interface. This is just a design pattern. This is the good old observer design pattern coupled with registering to a bus that has some events going through. So we just register as an iListener of whatever event type this component wants, and that causes us to create a handle method, and you see the refresh timer triggered. What should this component do whenever that event comes? Whatever that component wants to do. And oftentimes in this application, it was just calling another private method called, hey, refresh the entries that I'm showing, refresh whatever I'm showing. That's all it takes. All right, let me quickly talk to you about a library that you can use so that you don't have to do this all yourself. And it's called Blazor MVC. And Blazor MVC does two things. One, it gives you a pattern for separating your screen logic from your screen layout instead of having your C# code with your logic in the same code file or the same compiled object as your HTML for your layout. And it also gives you an implementation of a UI bus so that you can have eventing all around your screen. And I'll show you kind of what that looks like. And a quick demo here. So I pulled up the code, and I'm actually going to show you the implementation. Oh, not that one, this one. Okay, so let's say we're here, and for my counter, you see that I have a clock that's constantly changing. Okay, I'll show you the code behind the scenes, but there's some signal that is causing this to happen. This is not JavaScript. This is all 100% C#. All right, and of course it can do the counter. Then there's another situation where this button is somewhere. This button could be in the layout. The button could be in the bottom status bar. The button could be anywhere. And in this situation, the screen is composed with a top half and a bottom half. And if I click add another child, we're gonna notify, and then the component that owns this says, oh, I need to add another component. And so it creates a counter object. Well, guess what? It's the same old counter component, and the counter component is listening for this little timer notification, but I can do as many as I want. I've made my user interface dynamic with these notifications. If I go to fetch data, well, we just enhanced this one to, let's see, let me click on a row. So now we have a parent-child, and we can see the eventing used for parent-child communication. That's great. So I clicked on one that was freezing, and guess what? I added the eventing of when we're going to change our timer. But I can click, and there we go. All right. So let's look at the code. What makes this go? Well, if I look at my counter controller, which by the way, I've separated the counter view, which only has the markup and some properties. And of course, we can use our action properties for a callback. And my counter controller, which by the way, because the counter controller, it now happens first and it's separated, the counter controller owns the route instead of the view. But guess what? The counter controller, this is a Blazor component as well. The controller is a Blazor component, the view is a Blazor component. And so all we're doing is regular stuff. Now, check this out. Remember how we talked about iListener? Well, look at this. iListener of application heartbeat. Well, we have a handle method, application heartbeat, and all we're doing is setting the time, state has changed, we're done. Well, where does this, who's sending it? Well, that's where we can just go down to our app controller, which, by the way, in our program, we're saying, what app are we running? Well, we're using app controller and doing that. So we split apart our app from a controller and a view, because our view, we just want this regular markup. We don't want any controlling logic. And so we have the controller that pairs with it that, guess what? All it does is put in place a heartbeat controller and adds it. In the render fragment, that's how Blazor works. We're not going to go deep into render fragments today, but if I jump into the heartbeat controller, and I think it's in shared heartbeat controller, there is no heartbeat view, okay, because we don't need it. All we need to do is look at the timer and then send the heartbeat. So that's how that works. All right. Okay, let's go back. And time check, are we going for until 6:30? When do you guys drag me off stage?
We can go for as long as you'd like.
All right. Okay, so I just showed you how Blazor MVC does the separation of controller logic and view logic, and which, by the way, I will tell you that this is another 80% case. I don't care what application that you are working on, you absolutely want to separate code that controls behavior of a screen or a piece of a screen from code that formats or controls how that part of the screen looks, all right? And that's been the case for any application. So this is how it looks in Blazor. This is how to implement that architectural pattern for the user interface in Blazor. And you don't have to implement the pattern yourself, by the way. That's what open source libraries are for. So you can go grab Blazor MVC. It works for .NET Core 3.1, .NET 5, .NET 6, both server-side and Blazor WebAssembly. And by the way, if you want to change something about it, just go grab the source code, make a change, and then just compile it for yourself and use it, or submit a pull request. It's all good. So this is what the counter controller ends up looking like by separating the view and separating the controller. And actually, I need to update that because the handle event is supposed to be in the controller. All right, now let's talk about browser to server interaction in Blazor server side, because this is another wrinkle that you need to be aware of. Now, this is the performance tab. You hit F12 in your browser, go to the performance tab as you load a screen, and you're going to see all the different HTML frames as the DOM is being built when you're loading up a particular screen. And this one is from the car application in the screen where we're showing a tile for each car that's being sold. And we have a lot of cars, potentially a lot of cars. And you're going to set a page limit. Maybe you only show, 20 cars at a time, 50 cars at a time, whatever it happens to be. But either way, you're going to get a diagram that looks kind of like this, because the server side is streaming data with all these little packets going back and forth over the WebSocket connection to the Blazor.js that's running in the browser. And the Blazor.js is saying, oh, I've got more. Okay, hey, browser DOM, here's some more HTML or here's some more DOM elements to add to your browser. And the browser's just going to keep doing that. Well, that's going to cause the browser to appear really slow. I said appear. The browser DOM, by the way, will be the slowest part of your Blazor application. I don't care if it's WebAssembly or Blazor server side. The browser DOM, it's slow in every browser, unfortunately. So if you're building up a lot of elements in your HTML and you want them to show them to the user, sorry, there's no performance solution for you. And what's going to happen is you're going to have 100 tiles to show, and the browser is going to sit there building up the DOM, building up the DOM, building up the DOM, and when it's finished with number 100, then it's going to show the screen all at once. You ever wonder why a lot of sites out there that use React or Vue or Angular, they immediately come up, but they show you these gray rectangles that are kind of have this little animation moving back and forth while it's just waiting, and then boom, then the data shows up. Why? It's because of the DOM, because it's slow. It's not that the server's taking a long time to get the data up to the browser. It's that the distance, the time between starting the addition of all of these browser elements and when it's finished, it just takes a second or two. And so it's noticeable. But you can trick Blazor into segmenting those DOM change transactions by using the following code. All right. We have a list of 10 items. Now, I'm not talking about a grid here. We're showing them in a tiled fashion, so we're actually adding a lot of HTML to it. Grids are, the grid components that are available out there in the market are fantastic, and they handle this for you. But we're talking about where you are creating tiles, where you maybe have a little image and some different data points to it. And let's say we have 100, okay? Chances are in that situation, only a subset of that 100, in our case 10, are going to show without scrolling down. And of course, on a mobile phone, it may be only 2 before scrolling down. And so what we do is we separate the loading into 2 separate transactions for the browser's DOM. We do this by taking our 100, which, by the way, getting that data back from the database is going to be the fastest part of this. There's nothing to tune there. So you have them on this all items variable, this all items IEnumerable. And so we want to take the first 10 and set it to the items to display, which is actually bound to our markup in the Blazor component, and then tell the Blazor component, hey, the state has changed. Well, in a Blazor Blazor server-side application, this triggers the pushing of the changes through the WebSocket connection to the browser, and then the browser is going to take that set of changes and have that be a DOM transaction. And so it's just going to take 10. And 10 versus 100 is 1/10 of the time for that DOM change in the browser, and it's going to happen really quick. But state has changed doesn't stop execution. We're immediately coming back and setting items to display to the IEnumerable that has all 100, and then calling state has changed again. So the browser builds the first 10, and then at that point in time shows it to the user while we have another DOM transaction going on. That's the other 90. And so when you observe it, you'll see the page come up instantaneously, and then that 1 second later, then you're going to see the scroll bar on the side of the page get smaller, because now the page is longer. So that's how we can fake it, because the browser DOM is slow. And so if you have that scenario, use this trick so that your users don't notice that the browser DOM is slow, and go from one DOM transaction to multiple. Okay. I'm not going to go deep into this, but you will want broadcasted events. You will want to have some things that happen by a button click from one user, and you will want to broadcast it out to all of the other users of your web application. And when you're in Blazor WebAssembly or server side, you're really going to want to use SignalR broadcasting. Now, if you need data transfer to other users, then you're going to want to either use your SQL Server as a transport mechanism, or Azure Service Bus queue as a transport mechanism. But in the case of, hey, a price changed, it's no disaster if from time to time somebody's browser has a little network latency or whatnot, and one of those notifications gets dropped, because they're happening all the time. Just like dropped video frames when you're streaming a movie, they don't go back and recover the dropped video frame. They just kind of, oh, it dropped. Okay, let's keep moving. So same thing, when you have that scenario, you're going to want to broadcast some of your queries. And if you have translated everything that happens in your Blazor application into an object of some sort, then you can augment your bus and figure out what queries, what events, what commands need to be broadcasted. And you can also route them to a SignalR hub and do the broadcasting. Okay. All right, let's talk about testing. Unit testing, no different. Any other .NET application, no testing for unit testing until you get to your Blazor components, which are totally different. For that, there is a unit testing library called BUnit. And by the way, there's a episode of the Azure DevOps podcast from the founder and maintainer of BUnit. So you can search Azure DevOps.show for that. But this is what a very simple Blazor component unit test actually does look like in the car auction application. We can actually create a Blazor component bid dialog. And oh, by the way, this is also something else where if you have used the wrong interaction pattern for layout to component or parent component to child component and segmenting your screens, and you have tight coupling between the two, you're going to find it near impossible to do proper unit testing on your Blazor components. Also, if you implement an MVC pattern in your Blazor components and separate the layout from your screen logic, then you're going to find it a lot easier to do Blazor component testing as well for the behavior. Okay, and in your unit testing, you're really testing the behavior. There's no way that you're going to test how it looks. As much as you can get is the presence of an element, but you have to get your eyes on to see how it looks. But unit testing is really checking for behavior of, hey, we wanted an element or an entire section to be there in a particular case. We can check for that. Or we wanted it to go away in a certain case. Or when I clicked a button, when I invoked a button, I wanted something somewhere else in my application to receive some type of signal. We can test that with a BUnit test. And this is kind of how it could look. All right. For full system testing, we're going to want to use Selenium. Now, Playwright is a new testing framework that Microsoft is working on for full system tests. And I'm really excited to see it mature. But right now, today, as I stand here, Selenium is still the king for full system testing through the browser. And this is what one of the real tests does look like. In a few cases, the signaling from Blazor still, unfortunately, does cause us to have to, from time to time, just do a sleep statement just to wait for a little bit of time just to have a less brittle test. But most of the time, you can find some element that's going to pop up, and you can do a little loop checking for the presence of that element to know how long you need to wait. And so if you see down about 2/3 of the way down, you see driver.wait for test handle with a name of buyer sign in. You can make a method that kind of waits for the presence of an element that you give a particular attribute or name specifically as a handle for the test. And so it's perfectly okay to add additional elements and additional attributes so that your tests have a surface area, a hook to go into. It actually makes your test less brittle, rather than using a name or an attribute that's used for something else and may have a different reason for changing. And then when it changes, your test broke. Why? Because you used something that was really meant for somebody else. Okay. All right. So that's the full system testing. Here's another example of a full system testing setup. All right. I'm going to jump past this. Okay. Before I go into Operations Monitor, I want to talk to you about one more really, really useful pattern for WebAssembly and getting back to the server. And this is the pattern for how to set up your web services. So in any particular application, you are going to have any number of reasons to go back to the server. Okay. So let's say that you have a regular line of business application or a data collection application, a system of record application. Those things accumulate multiple hundreds of screens. All right. There's two different archetypes of applications that are out there, and you can force fit every application to these two types of systems. One is a system of record, and one is a system of interaction. A system of record, those are your old COBOL systems, mainframe systems, ones that when they were put in place, they house the data, they own the data, they move very slowly. You refactor these, you kind of upgrade them slowly. These do not just get wholesale rewritten. These get integrated with, these get built onto, and they move slowly, and every application has them. And for the most part, a lot of people hate interacting with them. And from time to time, a piece of the application will get rewritten and integrated into. Those are systems of record. Because they own the data, they're going to be around longer than we are.
Hey, Jeffrey,
systems of yeah.
we have a question. What does state has changed do?
Oh, state has changed is a Blazor method that tells the Blazor framework to re-render its markup. Now, if the code is in one of the Blazor lifecycle methods, then at the end of that method, the Blazor framework behind you automatically calls that method for you. But if you have code that runs outside of one of those lifecycle methods, then you just need to call that method to give the Blazor component a hint that something changed. Go ahead and reload your view because you might need to re-render your markup. That's what it means. It's not my method. It's part of the Blazor framework. Okay, so systems of record, on the other hand, get rewritten all the time because they don't own any data. They just provide access to a system of record. Think iPhone apps. Think client application. Think some type of terminal into something else. And systems of interaction typically have a few screens, but those screens get used a lot and they connect to another system of record. System of record, the number of screens typically has more of a proportional relationship with the number of tables in its database. So think about applications with hundreds of screens, okay? And I know every single one of you work on or have worked on in recent past a system that has just a lot of screens. It just has a lot of screens. That's just the way it is. And so when you have a lot of screens, and now you're thinking about the architecture of a Blazor WebAssembly application, there's going to be a lot of buttons. There's going to be a lot of reasons to call back to the server. And given those buttons probably need to be synchronous and blocking, there's going to be a lot of web services. And by the way, anybody that's done Angular applications or React or Vue, you have a lot of web services. So in an era with Blazor WebAssembly, where you're going to have a lot of web services, you need to think about how you want to support all of those different reasons to call a web service to ask for some data or update some data or delete some data or have the server, drop a file, dump, export on an FTP or network share, or all the different things that a server might need to do, okay? So lots of reasons to call a web service. In a Blazor WebAssembly application, let's say an application has 100 screens. Do we really want to have 100 web services? 100 web API controllers? Not unless we have to. That's a lot of overhead. I already have the button. And by the way, that's why a lot of people go towards Blazor server side, because they don't have to. Let me just run it all on the server. I don't even need this extra layer because my code has to jump from the browser over a network back to the server. The code's already on the server. That's why a lot of people jump to Blazor server, because the thought of 100 web services is just absolutely unnecessary. And why would I do that? Oh, that's all that effort. What return on investment am I giving? Okay. In the absence of an architectural solution, developers are confronted with a mountain of work. So when you're confronted with a potential mountain of work, don't just run straight into the mountain of work or turn around and avoid the mountain of work and do a different application type. Think, is there an architectural solution here that basically eliminates 95% of that mountain of work? And in the case of these web services with WebAssembly, there is. Let me show you one. All right, so before I walk you through the code, I'm just going to show you the application here. And okay, so in the counter component, I'm going to click. Now we have an extra response, and it's number 3 from server process, and we just grab the assembly name of what's running on the server, just to prove that I did call over a web service and I did jump to the web application. And on fetch data, we're kind of jumping a load data. We jumped over to a web service, got it, pulled it back. I'm going to select one of the records, and we have a child process, additional data, and I'm going to click update, which is going to do an update record to our database or simulate it on the server. And boom, instead of scorching, it was updated. If I do the top one, which is chili, hit update, boom, it was updated. All right, so pretty darn simple. Now let's go back and just click, 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 click. This is just adding 7 plus 2. Got it. All right, let's look at the code. This is our WebAssembly application, and this is our server-side application, but let's just go to the WebAssembly application and see that there's not much there besides, and I didn't even implement Blazor MVC on this one. There's not much there except for what we put into the file new project. But if I go to counter, you will see that there is something different. On increment count, I actually have my bus implementation, and I just sent, hey, counter query. And effectively, this is saying, hey, give me, I'm querying for the counter, and it's going to query for the counter on the server, and then a return value. Okay. If I go in shared, bus does not exist in this project. Bus exists in our shared project. Okay, it's shared. iBus. There we go. If I go to program, you'll see a few of the dependencies that I've pushed into here. And iBus, the implementation we're using for WebAssembly is the remotable bus that allows us to take a query object, toss it over the wire to the WebAssembly and get it back. And then we have a publisher gateway, which I'll talk to you about first. And then, of course, we have a configuration key, which is the URL. By the way, it's in app settings, which is the URL of our server application. Always need that. Okay, and then publisher gateway needed a HTTP client, so that's how we're doing that. All right, if I go to the server, just to show you the program here, the setup, let's see, right, yeah. Notice on the server side, I'm using the default implementation of the bus, not the remotable bus. So that's our switch. Okay, let me show you the iBus. Basically, I can send a typed object, I can send any kind of object, and I can publish a notification. All right. And let me just walk you through the code one piece at a time. All right, bus.send. I'm just going to use my ReSharper shortcut keys to hit Control-Alt-B, jump into bus.send, and I'm going to do the one in the right here. And in the remotable bus. Okay, so now I'm in remotable bus, which is down here, web API, in the shared remotable bus. This has dependency of iMediator and publisher gateway, okay? And we're gonna check if the request implements the marker interface, iRemote request, then we're actually going to ask our gateway to publish it, and whatever we get back, we're going to return. What do you mean iRemotable request? Well, if I have my queries here in the shared project, counter query implements iRemotable request. Now, some of you have or have not worked with records yet. A record class is just a different type of class. If I were to take this and just change it to be a class, then boom, that's what it would look like without the get hash code and equals and double equal operators, but effectively, just a property. So if I want to undo that, I can undo that just by Control Z, but I just happen to use a ReSharper shortcut key to convert a record to a class. A record is just a type of class. You can read up on about it. But so this object right here is very simple. It implements an iRequest that returns back a server count, and it implements our marker interface. A server count only has the new count and the process name. All right, so now we are in publisher gateway, and I have one of those queries, and the publisher gateway takes the request and puts it into a web service message. If anybody has ever used the Azure Service Bus SDK and many other remoting or queuing libraries, you'll notice that there is a message type that you either have to wrap up or you need to inherit from, and you put your message, your data, inside its type. And its type has some intelligence. Its type acts as the envelope to go over its mail service to the destination. So if we implement that same pattern here with a web service, well, then we have one web service that can act as an envelope for any number of requests or commands or events to go back and forth to the server. And so this is one, I'll show you web service message in a little bit. But down here, all we do is we take that web service message, we post it as JSON. When we get the results back, we translate it back into a web service message and send it back. All right, let's jump into web service message. Control B. It has basically the body as JSON of whatever request we sent into it, and then it has the actual fully qualified type name of the actual request that we sent into it. And so here's where we're getting the type name, get body. All we're using is the built-in JSON serializer. That's all we're doing. And if I want to get the body back out as a generic type, I can do that. Or I can use the built-in type to just do JSON deserializer. Okay, so now let's jump into the web service controller, which is on the server, and there's only one of them. And guess what? It receives a web service message. It's a post. It has a very predictable, simple URL to use as the route. And when we take the web service message, what we're doing is we're saying web service message.getBodyObject. Well, now we have the counter query. And now I'm just resending it to the bus instance that's running on the server that knows how to route a counter query where? Well, to the counter handler, which I'll show you right here. The counter event handler. And this gets the process name and it takes the count, adds 2 to it. By the way, if I was querying for a customer or an order, I would have a customer query and I would send it back here. And the handler on the server side would have some code that talked to Entity Framework, which talked to SQL Server, which sent a select statement and then populated the customer. And then I would just return task of customer. Okay, that's how on the server you go to a database and get it back. But either way, you route it through this way, through the web service. So now we're adding 2. Just to prove it to you, why don't we take this and multiply it by 100? So let's hit Control. Oh, I fat fingered something when I was moving something else. All right, you'll just have to trust me on that. But when I go here, yeah, when I was moving around, I fat fingered it a little bit. I'm not going to take your time up for that, but that is the pattern to have WebAssembly with a web API controller on the back end and have exactly one web service, and you can protect it from cross-origin requests so that only your WebAssembly application can actually call your web service, and you can wrap it with any other authentication or security you want to wrap it in. But there's no reason that your application that has 100 screens needs to have 100 web services. Now, a web service with Swagger and all this cool stuff is great when you're actually needing a web API in a public API, more of an SDK. When you need other third parties to talk to your application, web APIs are awesome. They're awesome. And you can have documentation and all that. It tells people how they can call you. But if you're creating a WebAssembly Blazor application that is just split between the browser process and the server process, you're not publishing any web services for third-party components. All you want is a way to jump over the network. All you want is a remote procedure call. You don't want to publish a public contract or public API to other people. It's only for yourself. So you don't need compatibility with everybody else and documentation. You just need it to jump over the network for you. Okay, so consider that type of pattern when you may be tempted to change your architecture just because you're staring at a mountain of web services work. When really one architectural pattern, you solve it. And then you can just blow and go, and you can add screens and buttons, and you can package up the user intent as an object. You can pass it down a bus. and then your remote bus just pops it over the wire, and now it's on the server side, and it goes through Entity Framework, goes to SQL Server, does whatever it does, and then just comes back and pops over the wire and back to WebAssembly. So consider those types. All right, let's finish out with how to run your Blazor applications in production. Your Blazor server-side application, remember how I said you're hosting your user session on the server and you're just giving them a terminal into it. Well, that's going to take more memory. That's going to take more CPU because you're running instances of the application for the user. So of course it's going to take more resources. Hey, that's just part of how that architecture works. You also need low latency, so you're going to need to monitor that. You're going to want to, for both the application types, this is WebAssembly and server-side, you want to instrument what your users do, not just what the application does. And I'll show you an example of that. And then regardless if you're just hosting web services or if you're hosting full Blazor server-side, you definitely want to move your hosting plan onto the version 3 instances. They came out last November. They're twice the power, half the cost. If you have not redeployed your Azure hosting plan server applications to the V3 instances, you are paying twice as much as you need to. Okay, so be aware of that. This is what you're looking for. The P1 V3, by the way, if you're running a just web services, you could run P1 V3, but that might even be overkill. You probably even use S1 in some cases, depending on your load. But if you're running a Blazor server-side application, the minimum to reach for is P1 V3 because it has the extra RAM, the 8 gigabytes, and make sure you're running a 64-bit. Stefan Shakow is one of the architects on .NET applications running in app service, and I interviewed him on my podcast, and he literally said, if you're running a Blazor server-side application, don't reach for anything lower than P1 V3 because of the memory requirements, even in normal cases. So that's kind of a rule of thumb. Now, what are some of the metrics that you want to make sure to have in your application insights dashboard? Well, here's 2 of them: server response time and average receiving response time. If on the server the only thing that's running is a web service, well then you probably have a lot of experience looking at metrics for web services when that's all you're serving. If you're serving a Blazor server-side application, server response time is going to be really important to monitor because we talked about latency and network jitter and responsiveness of getting all these little small back and forths, but there are a lot of them back and forth to the browser. And so you want to make sure that your server response time does not go above 10 milliseconds. What we found is for Blazor server-side applications, once the server response time starts averaging over 10 milliseconds, you start to perceive it as a user. You start to see the lag between when you click on something and something changes. And so if you keep that below 10 milliseconds, then you're going to be sitting pretty. For the receiving response time, when data kind of gets over the wire, what we found is that when we start averaging over 100 milliseconds, then we can start perceiving the slowdown. So as long as you stay under 100 milliseconds there, then just from the human eye, you really can't tell the difference. And so you'd be good there. We've done a lot of custom auto scale based on memory for Blazor server-side applications. You can do manual, and this is what it looks like, and probably everyone's familiar with that. But for Blazor server-side applications, what we found is memory, not CPU, is typically the case where we decide to add more instances to the app service. And so if you use the custom auto scale, you'll want to put some rules around memory consumption. We did not find that CPU consumption was the factor for Blazor server side. We did find that memory consumption was. All right, and now instrumenting what people do. Here is a magic graph. You want this type of graph for yourself. Remember I talked to you about the car auction application. This is last summer where we saw that for a particular use case and in a particular market, the usage went up, but we saw some seasonality. And so we saw on the weekends, at the end of the week, there was more traffic, more auctions. And in the middle of the week, car auctions in this market didn't happen very often. And so we saw this type of seasonal traffic on a week by week basis while it grew throughout the summer. Okay, and these are the number of events in this particular production environment in this market, and you see the checkboxes for a certain number of commands. Now, remember what I talked about packaging up the intent of the user as objects. This is the epitome of object-oriented development. And when it comes to Blazor applications and monitoring Blazor, this just brings it all to light. And so behind every button click in your Blazor application, instead of immediately thinking, oh, what method can I call of whatever class? Instead think, wait a minute, what did the user just want to happen? Let me create a really tiny, simple data transfer object, little tiny marker object that represents that. And if I need one property of something, put it in. If I need two properties of something, put it in there. And then let me take that object and pass it through the application. Then if you implement a hub and spoke pattern, so you have a pinch point, and my favorite hub and spoke pattern for these types of applications is a bus. And so you pass this object down the bus, and all the handlers or spokes that are registered with the bus kind of get a look at it and say, oh, that one, I'm interested in that. I can do that. Let me take that and let me handle it. And then it's routed to their handle method, and they call whatever they need to in SQL Server or wherever to do it. And so we've checked some of these boxes, which these are the names of C# objects. And the bus has pushed each one of them to Application Insights as a custom event. And so submit new bid, register new buyer command. These represent general usage levels of the car auction application, and we can see that. Also, the green check marks up top are from Azure pipelines. Every time we deployed to production, the deployment process actually told Application Insights, hey, I'm deploying to this environment. And so now we can see the change of our metric graphs onto a graph of how frequently we were deploying to the production environment. So if we did a deployment expecting the metrics to change and it didn't, well, that tells us something, and vice versa. Also, specific to Blazor server-side applications, for those applications, we really wanted to know how many open sessions or open circuits were open per server instance. And so this is a graph of the open circuits. And by the way, there is a circuit handler in the Blazor framework that lets you override some methods and do your own logic whenever a new Blazor server-side circuit opens up, which has a high correlation with that WebSocket connection back to the server. So you can when it opens, when it connects, when it disconnects, because some of the network could go up and down, and it could be connecting, disconnecting, while we keep the memory around. So you want to keep track of that for yourself, and you can run your own logic on that. And then here are those circuit graphs that we kind of add the open circuits, disconnected, connected, and then we also add memory percentages. For all of our instances, we always tend to put those on our dashboard. And this is the tracking circuit handler that I mentioned. All you do is override some methods of circuit handler and do whatever you want. It can be as simple as just incrementing a counter, or you could do something more complicated. All right, that was a lot of information, and I appreciate all of the attentiveness. I'll put my email address back up here if anybody has any questions after the fact or would like a copy of the poster or my book or anything. So I appreciate the questions that we did come in, and if we have more questions now, I want to have a discussion, I'm game for that.
If anyone would like to ask Jeffrey a question, please feel free to unmute and ask your questions now. Thank you.
Hi, Jeffrey. This is Nick Stein. Can you hear me?
Howdy. Yes, sir. Yes, sir.
I came up with that bus idea of wrapping it so that you knew what type it was going to be with the JSON, or actually it was XML when I did it. Yep. A long time ago, and I've never seen anybody else use that. And I wanted to say that is the best tip I have ever heard. Being able to send messages and have the message smart enough to know what it wants to do with it is just unbelievably efficient, and just makes your development so much easier. And I would like to review what you did there. Don't suppose you have any iBus source code around.
For the web service message for that sample.
Yeah.
So you know what? Send me an email and I'll zip it up for you. I don't actually have that particular one published to a GitHub repository at the moment, but just send me an email and I'll be happy to give it to you.
I would be doing that. That is such a great tip. I cannot express how overjoyed I am to hear that.
Well, there's so many ideas that aren't absolutely new, and there's so much prior art that if you just think about it, can easily be adapted to the Blazor project type. And you're right, XML, it doesn't matter what the serialization or what the transport format is. We could be using XML from JSON. Heck, we could be using a binary serializer and just stuff it into a binary array and then get it back on the other end. The fact is, you have a mechanism for getting it across the network.
But the idea of being able to use a myriad of different kinds of objects coming across the wire that way and allowing your transport layer to be simplified that way is just beautiful. So thanks for that.
Yeah, you're welcome. You're welcome. Rick, do you want to ask your question on mic? Let me see if I can get to it. Where's the chat?
He asked, so hub and spoke is very similar to CQRS.
Okay. Yes, go on. Or you just asked me to comment on that. So hub and spoke is a way of thinking. It's a general family. And that is create a hub, which is an abstraction. A lot of objects go into it, and then they get routed different places. So that's a general paradigm, a way of thinking. Then you have all the little individual patterns, and some people have patterns that overlap, and it can get confusing. That's why I like to talk in general terms. CQRS is as it's been defined and written about, is a lot of things, but the big idea that I like to pull from CQRS, which stands for Command Query Response Segregation, is the notion of taking what the user or what a particular part of a program is doing and packaging up what it wants as a query object, or what it wants to tell somebody else to do as a command object, or what has already happened as an event object. And now you have objects, and those objects can be routed in all kinds of different ways. And the big idea is as old as object-oriented programming. The big idea is objects. Okay, structured programming had us have one class, a method in a class, call a method in another class, which calls a method in another class. Object-oriented programming is package up and encapsulate some data, which is a property, 2 properties, 3 properties, package up some data. Now you got an object, and that object can move around and be sent. Okay. And so it's a very different coupling result that happens from passing an object to another class and along some pathway than one class calling a method in a specific way of another class. And so that's the difference between having repository interfaces and then just a query object. If you depend on a repository interface, yes, it's an interface. So we think, oh, an interface is an abstraction. Well, repository interfaces are pretty darn specific. And so I contend that a repository interface is merely an indirection, allowing you to have one implementation of that repository interface that happens to do some data access. And so the more valuable abstractions, in my opinion, are the abstractions that have many implementations, and the number of implementations grow over time as your application grows. And so that's where the hub and spoke type of abstractions, you have more and more spokes, more and more implementations of that abstraction, which, yes, it's a C# interface over time, as opposed to customer repository, which maybe has 1, 2, 3 methods and probably only one class that ever implements it, unless you layer on something like a cache. But yes, CQRS, the big idea is actually expressing or actually capturing the intent of the users of the user interface as objects way up in the user interface layer in your Blazor components, and then passing that object down into your application. All right. Any other questions or comments?
All right. Does anyone have any more questions for Jeffrey? Going once. Going twice. All right. I'm going to shut off the recording. Thank you very much, Jeffrey. This was a really cool session. I really enjoyed it.
Oh, my pleasure.